Chalking is not a sudden failure, and it is not a dirt issue. It is the final visible stage of long-term polymer degradation in automotive coatings. When chalking appears, the coating has already lost a significant portion of its structural and protective integrity at the surface, even if the film still appears intact from a distance. From an OEM durability standpoint, chalking occurs when ultraviolet radiation, oxygen, heat, and moisture progressively break down the polymer backbone of the clear coat or top coat. As chemical bonds are broken, the polymer chains lose molecular weight and cohesion. The degraded fragments migrate to the surface, forming a fine, powdery residue that can be wiped off by hand. This residue is not contamination. It is the coating itself. The reason chalking appears late in the life cycle is because clear coats are designed to sacrifice themselves. UV absorbers and HALS slow degradation, but they are gradually consumed. Once these protective additives are depleted near the surface, UV energy penetrates deeper and accelerates polymer breakdown. At this stage, gloss has already dropped significantly, and surface roughness has increased. Chalking is closely linked to gloss loss, but represents a more advanced failure. Gloss loss occurs when micro-roughness scatters light. Chalking occurs when the polymer network has degraded enough that solid material detaches from the surface. This is why chalked surfaces often appear dull, faded, and dry, even after washing. Pigment choice influences chalking behavior. In clear coats, there are no pigments to shield the polymer, so additive protection is critical. In single-layer topcoats or colored clear systems, certain pigments provide partial UV shielding, slowing chalk formation. However, once the binder degrades, pigments themselves can be released, intensifying the chalky appearance. Cross-link density again plays a balancing role. Highly cross-linked polymers resist chemical attack, but degrade more brittly under UV exposure, leading to faster surface fragmentation once degradation begins. Lower cross-link density systems degrade more slowly, but may lose gloss earlier. OEM systems are optimized so that chalking occurs only beyond the intended service life. Curing quality strongly affects chalk resistance. Undercured coatings retain unreacted groups that oxidize easily, accelerating degradation. Overcured coatings develop high internal stress and microcracks that increase oxygen and moisture diffusion. Both conditions shorten the time to chalking. Environmental conditions dictate chalking rate. High UV intensity, elevated temperatures, and low rainfall accelerate chalking because degraded material accumulates instead of being washed away. This is why chalking is more visible in hot, dry climates. In humid or rainy regions, degradation still occurs, but the chalk residue may be less obvious because it is periodically removed. Once chalking begins, protection is compromised. The surface becomes porous, allowing rapid ingress of water and contaminants. At this stage, polishing can temporarily improve appearance by removing degraded material, but it also reduces remaining film thickness, accelerating future failure. OEM durability targets assume no aggressive polishing during service. From a testing perspective, chalking is evaluated using long-term weathering tests, such as xenon arc exposure combined with visual and weight loss measurements. OEMs correlate these results with outdoor exposure in severe climates. Systems that chalk prematurely in lab testing rarely survive real-world conditions. Troubleshooting chalking complaints focuses on exposure history, additive depletion, and cure verification. Additive adjustment is a formulation-level decision and not a plant-level fix. Process deviations that accelerate chalking include insufficient bake, incorrect film build, and contamination that interferes with UV stabilizers. Chalking is not merely an appearance defect. It is a signal that the coating's protective function is nearing the end of its life. When coatings are engineered correctly, chalking should occur only after many years of service, beyond warranty expectations. If you have questions about chalking long-term weathering failures, or why some vehicles powder while others age gracefully, leave them in the comments. We'll continue breaking down advanced durability failures and OEM-level prevention strategies in the upcoming episodes.